In this module, we'll talk about the concepts of fields which basically affects the overall behavior of the particles. So let's get started. In this clip, we'll talk about the gravity field. Let's play the animation and see the effect of the gravity. The gravity field here is simply creating an effect of Earth gravitational pull, which is a kind of force that is dragging the particles in the downward directions. This is how the gravity works in the real world, alright? So let's close this and let's start with our process. So let's do one thing. We have a 3D text, a polygon mesh over here. Now let's start emitting particles from this mesh. So we can go inside the End Particles menu and use the option Emit from Object. I would like to go with the emitter type as a surface and use a rate with a fairly high value, that is 15,000 particles per second. Let me also get rid of all the speed attributes because we want particles to stick up onto the surface of this mesh, so that's why we don't want to use the speed. Hit the option Create. Now if I play the timeline, you can notice these particles are still falling under the impact of the nucleus gravity. Well, you might be thinking that if we are having the nucleus gravity, then why we are creating an external gravity? Well, both these gravity fields are working in a similar way. Both these are executing the Earth gravitational pull and everything they are doing the same, but the only good thing is the external gravity field is providing with more customizable attributes, and based upon which we can create some more interesting effects. Alright, so let's get rid of this nucleus gravity first of all, and let me go inside the dynamic properties and use the option Ignore Solver Gravity. Now let's move to the shading sections and reduce the point size to a 1. Roll back the timeline and hide the text. Now if I play the timeline, you can see we are now having the particles. Particles have started encapsulating the entire mesh or the entire surface. But if I roll back the timeline, you can notice the particle will just lost and they are just gone away from the scene. So how are we going to freeze, or how are we going to store the position of the particles, which was at roughly around 80 frame or maybe at 75 frame? Well, we can do this thing while initializing the values. So we can select the particles and go inside the field solver menu. Under the initial state, we have set for selected. So if we click this and if we roll back the timeline, you can notice now the particles are stored. Now the position is stable, and whatsoever the value was at the current frame, maybe at 50 or maybe at 60 frame, we have taken that value and we have passed on that value at the first frame. So with this, your particles are now stable. Alright, so let's do one more thing. Let's select the emitter and give the rate a value of 0, or you can also even delete the attribute, because if we don't do this, then new particles will keep on emitting, and that is we don't want. Alright, so now let's do one thing. Let's select the particles, go inside the field solver and click the gravity. So here is the gravity field. It has its own interesting icon which is pointing in a downward directions, and if you play the timeline, you can see now the particle text is falling down and all the particles are instantly falling down. What if we want to create some fall off, or what if we want to create some range in which only few particles, or you can say certain section of this text should get effect? Alright, so let's do one thing. Let's press Ctrl A, the attribute editor for this gravity, and let's explore an interesting attribute, that is the attenuation. Well, this particular attribute is a distance based attribute, and it will reduce significantly the magnitude of the gravity based upon the distance. So it simply means that if your gravity is away from the particles, the effect of the gravity will get reduced. The maximum magnitude you can have is only near to this point, which is this icon. Let's do one thing. Let's create the value. Let's increase this attenuation value to a 3, and let's play the timeline. And now you can see that the particles are slowly and steadily are getting affected. Let's do one thing. Let's select this gravity and bring this gravity over here. So if I play the timeline, you can see now the particles which are near on the gravity, they are falling first. Alright, but this is not the kind of effect which we are looking. So let's do one thing. Let's first of all provide this gravity with some range. Alright, let's get rid of this attenuations. And if I play the timeline, you can see particles will continue to move down. So let's do one thing. Let's introduce the range. So we can use a volume shape, and out of any of them we can create. Let me try out with the sphere. So if I play the timeline, you can see the particles are not falling because these particles are not inside the range. So this is the beauty of this attribute. Until unless the particle is not inside this range, they will not get affected. So if we increase this range, and we take this slider, or we take this range close enough to the particles and play the timeline, you'll see now the particles will start falling. Alright, but this is again not like that much interesting motion. So now let's use the attenuations. Okay, so let's use a value of somewhere around 4, and let's also increase the magnitude to a significantly high value. Let's say we use a magnitude somewhere around, let's say 800, and let's do one thing. Let's use this interactive playback, and now you can see. Alright, so this is very interesting. But let's also do one more thing. Let's reduce the the magnitude of the gravity. This is really very high value. Let me bring it back to the 400, and if I play the timeline, you can see now the effect is really very nice. Alright, so we can also do one more thing. We can increase the attenuation. Let's say we go with the value of 8, and now if we play the timeline, you can see now something more nice is happening, because now your particles will fall more slowly because due to the increase of the attenuations. Alright, so you can keep experimenting with this value and can get back to the effect based upon your own artistic decisions. Alright, so that was a look inside the gravity field. Now we'll take a pause over here. We'll move to the next clip where I'll talk about the Newton field.